right, good day. Welcome to Math Made Easy. And I think the last time we did indices, and today we'll be looking at sword. We're supposed to go to log reading, but let's deal with sword first. We're looking at sword, and when talking about sword, basically sword are in form of irrational numbers like roots. So when we talk about roots three, for example. Now, most times we'll say it's square root, right? If it's like this or there's something here, two square root. If it's three, cube root. If it's four, four cube and the likes. So, but without using, it's supposed to be called square root two, right? But in short, it's called root three. We can have root five, root 14, and the likes. Now, I'm going to simplify um, sword because in mathematics you can actually use your answer in solid form but make sure it's simplified. For example, root 48. Now the easiest way I tell students to simplify solid is that they actually look for the highest perfect square. What do I mean by perfect square? We have 1 times 1, that's 1, that's a perfect square. 2 times 2, that's what, 4. 3 times 3, 9, 4 times 4, 16, and so on and so forth. Now, you go like that 5 times 5, 6 times 6, all those are called perfect square. They are called perfect square. So, if you look at this, what are the factors in 48 that are perfect square? We have 4, right? 4 is there, but that's not the highest. The highest perfect square we can see is 6, 16 rather. The highest perfect square we can see is 16. So, when you are simplifying a sword, you remove the highest perfect square you can get from that sword and you simplify it. Now, how do you simplify this? The highest perfect square you can get is 16. 16. So 16 times what will give you that 46. That's 16 times 3, right? Then the next thing we do is what? Separate it. Root 16 times root 3, right? Then we separate it again. Root 16 is actually square root of 16 because it's a perfect square. Now, square root of 16 is what? 4. So we have 4 times root 3. So we have 4 root 3. That's the simplification of what? Solid. Now we can also look at this example, root 150. Now the reason why I'm doing this example because most people might think it's only prime number or something because 3 is a prime number. No, most times are prime numbers and also numbers that once you remove the highest perfect square because we have times where you can have 16, 14, and the likes. That doesn't mean you are wrong because it's not maybe a prime number or something. Now let's look at this. The highest perfect square here is 25. 25. That's the perfect square set you can see here. 25. There's no other perfect square you can here. Right. So we are going to separate it. 25 times what? 6. Alright, so we have root 25 times root 6. We have 5 times root 6. So the answer is what? 5 root 6. That's it. That's it. 5 root 6. Now, in talking about I want to quickly deal with something still under this the other sword. Now, if you look at sword, there are ways to do it. If you want to look for um the perfect square, if you don't know how to look for perfect square, just use your set, but that's longer. And the reason why I'm introducing it is because some people might not quickly know how to figure out the perfect square. So you just use LCM. For example, we did 48 now. How do you do the LCM in 48? You know LCM 2. Looking for the factors. 2 in 48, we have 32, right? So in 32, we have 16. Oh, sorry. 2 in 48 is not 32, it's 24. 24. 2 in 24 is what? 12. 2 in 12, 6. 2 can still go 2, 3. 2 cannot go again. Go to the next number, 3. That's 1. So we have 2, 2, 2, 2, 3. So basically, you do 2 times 2 times 2 times 2 times 3. Now, if you can group a number that appear twice, it's a perfect square. Look at it again, we can still group this number, right? That's a perfect square. So it means that this number is 4, this number is 4. It still appear twice, so we group it 16. That's what we have as a perfect square earlier, right? So we're just quickly going to do rationalization, and we're going to stop here. Next, we're going to do the conjugation, but let's just do rationalization and stop here. Now, when we talk about rationalization of surd, we talk about using fraction when we have numerator and denominator, right? Now, in surd, you can leave a numerator as the answer. Surd, the numerator can be in surd form, but leaving the denominator in surd form is not acceptable. Do you get it? So that's why we have to rationalize. So when we say rationalize, maybe rationalize 2 over root 3. Well, what the question is saying, or what we are saying is that this root 3, we don't want it to be in the denominator. It can be in the numerator, that's the up one, but we don't want it in the down place. Do you get it? So now, how do we rationalize? We rationalize by using the denominator to multiply both the numerator and the denominator. What is the denominator? What is down here? Root 3. So it means that to rationalize, we multiply up and down with what? Root 3, root 3. So our final answer, 2 times root 3 will be, you just, because they are not of the same, this is a whole number and this what is short form. So just say 2 root 3, right? Yeah. Once you have two surds, the same number, the same value, root 3 times root 3, just throw the root, pick the number, and that's our answer. So root 3 times root 3 is what? 3. Let me do one more example and we call it a day. So 3 root 2 over 2 root 5. How do we rationalize? What is down here? 2 root 5. So you multiply up by 2 root 5, multiply down by 2 root 5. Now this is a bit complicated than the former one, right? Now what do we get? With this one, we have whole number here, we have whole number here. So we multiply them. This whole number 3 times 2 is what? 6 times root 2 times root 5. Now, because they are not of the same value, we have root 2, we have root 5, and they are not of the same value. So you multiply them. 2 times 5 is what? 10. So we have root 10. Now, the down, the same thing. 2 times 2 is what? 4, because they are both whole numbers. I remember I said if you have two surd form that are the same value, you pick one and throw this. So root 5 times root 5 is just 5, right? So our final answer will be 6 root 10 over 20. Now, because 6 is a whole number, 20 is a whole number, you can still reduce it. 2 will go here, 3, so we go here, 10. Now, your final answer is what? 3 root 10 over 10. Now you cannot say 10 cancel 10 because this one is 10 in a whole number and this one is 10 in the sub form. Alright, so thank you very much. We end here for today. The next time we'll be looking at conjugation of salt and also we'll look at addition, subtraction of salt. Thank you.